So here we have another sequent, 3 premises and a conclusion. The conclusion is a conjunction, so is the third premise. Second premise, a disjunction. First premise, a biconditional. So the first premise says either P or Q if and only if both R and S. That's our first assumption. Second premise says either Q or T. And the third premise says both not T and not U. The biconditional, the rule that applies to it, the elimination rule, double arrow elimination, allows us to take out one of the conditionals, either the left to right conditional, if either P or Q, then both R and S, or the right to left conditional, if both R and S, then either P or Q. So we could take out both of those conditionals right away. Question is whether we need to. The disjunction, well, wedge elimination is a 2-line rule, not a 1-line rule like double arrow elimination or like ampersand elimination. So we can't do anything directly with 2, but if we could get the denial of one or other of the disjuncts, then we could prove the other disjunct. And we can do that because the denial of the right disjunct of 2 is the left conjunct of 3. So one thing we could do is take out not T on line 4 and use it together with 2 to prove Q on line 5. Well, we could do that. Why would we do that? We need to look at our conclusion. So we look at the conclusion and we see it's a conjunction R and it's not the case that U. And we would have to prove it on just these 3 assumptions. Well, it's a conjunction. So probably we'll use ampersand introduction to prove it. Not always true, but usually true, or often true, that you use the rule that introduces the main connective of the sentence you're trying to prove. And the right conjunct of this conjunction that we're trying to prove is actually the right conjunct of the conjunction on 3, so we know we can get that. We can just take it out right away. 3 ampersand elimination, a 1-line rule. So the work really goes into proving R. Once we've done that, we'll put 4 together with whatever line number R is on to get our conclusion, both R and not U. So the task now is to prove R. Well, R is here. It's in a conjunction, so if we can prove both R and S, then we can take out R by ampersand elimination. But to prove both R and S, we'll need first to take out the conditional, the left to right conditional, if either P or Q, then both R and S. We'll be using arrow elimination, but that is a 2-line rule, so we need to prove either P or Q. Well, Q is here, and we can get the denial of the right disjunctive 2 from 3. So first we take out not T from 3, ampersand elimination again. 1-line rule, so the assumption set is just the same as the 1 line that you're using, which is an assumption, so it's 3. Now the wedge elimination. Here is a disjunction on 2, and here is the denial of its right disjunct on 5. So by wedge elimination, we get the left disjunct, Q. That's from 2 and 5, and so the assumption set is 2 and 3. Here comes the funny bit. If Q is true, then either P or Q must be true. there's no way that the sentence on 6 could be true without the sentence on 7 being true. And that's wedge introduction, the rule that allows us, from any sentence we already have, to prove a disjunction having that sentence as its right disjunct or its left disjunct. Again, it's a one-line rule, so the assumption set is just the assumption set of the one line. Now we take out the conditional, the left to right conditional, from 1. So we get if either P or Q, then both R and S. That's one double arrow elimination. A one-line rule. And now 7 and 8, well, here is a conditional on line 8. If either P or Q, then both R and S. And on line 7 is its antecedent, either P or Q. So 7, 8 arrow elimination gives us the consequent of the conditional on 8, which is both R and S. So we used 7 and 8. 7 rests on 2 and 3, and 8 rests on 1. So 9 rests on 1, 2, and 3. And then on line 10 we take out the R, the left conjunct. 9 ampersand elimination. Assumption set stays the same. And then finally on line 11 we put together R from line 10 and not U from line 4, and we have proved R and not U, the consequent of the sequent, on assumptions 1, 2, and 3, which are our three premises. So here we have a proof in which we use ampersand elimination, wedge elimination, wedge introduction, double arrow elimination, arrow elimination, and ampersand introduction.